Okay, so in previous we have been discussing about the introduction to process dynamics and control. That is, why do you require process dynamics and control? To know about the various parameters that are required for the process to undergo, or environmental issues that are to be solved. To know about the external disturbances, how that can be reduced, how the external disturbances can be reduced, and how can the process designed it should be an environmental safe, etc., and how the control system is used for controlling the output response, or based on the required values we will use a controller which has a valve connected to that. Through that it will develop some error. With the help of that error you can determine whether the control valve should be opened or closed, or there should be no action that should be taken. Okay, so now we will see how the basics what are required. The mathematic tool that is required for solving is Laplace transforms. The mathematical tool that is required for solving the problems in process dynamics and control is Laplace transforms. Laplace transform is nothing but it gives or it takes the parameter or input in the form of time response. In the form of time response, and gives the output in the form of frequency. A function or an equation or an expression that takes an input in the form of time and produces a frequency outcome or response is known as basically Laplace transform expression. It is given as Laplace transform of any function f of t. Laplace transform of any function f of t is equal to integral of e power minus st f of t dt. Integral of e power minus st f of t dt from 0 to infinity. And Laplace transform of a function f of t is equal to e power minus st f of t dt integrated from 0 to infinity limits, and the output that you get is known as output response in terms of f of s is a function. In terms of frequency you get a response as output, which is given as f of s. So Laplace transform of f of t is given as f of s, which is equal to integral 0 to infinity e power minus st f of t dt. Okay, so now let us see the Laplace transforms of various functions. Let us see the Laplace transform of various functions. Before that, one or two I'll tell you the examples. So Laplace transform of t is equal to 0. Let the function f of t is equal to t. So Laplace transform of t is equal to 0 to infinity e power minus st. F of t is nothing but t in our case dt. So apply u into v rule. UV rule, and it should follow the concept of ILATE. Integral UV, that is integration by parts concept you will be using, and in there you will use the small term called ILATE, which is used to select the u value. Exponential term, algebraic term is the first value. So this will be your u and this will be your v. So what is the integration by parts? U into integral v minus integral of du by dt into integral v dt. Right? This is the integration by parts formula. So t into integral of minus e power minus integral of e power minus st over minus st from 0 to infinity anyway it is. Okay. Final at last you can substitute the limits e power st into minus divided by, it is not the function st, so it is not e power t, right? It is minus st. So again divided by the differentiation of st. In the same way you have to solve this. integration d by dt of t is nothing but 1. Integral e power minus st is minus of e power minus st. Again integral of integral e power minus st will give you minus of e power minus st, so plus e power minus st you get, and substituting the limit 0 to infinity you get Laplace transform of f of t is equal to 1 by s. Laplace transform of t is equal to 1 by s square. Sorry. Laplace transform of e power t, Laplace transform of t function is 1 by s square. When you solve this, substituting the limits from 0 to infinity, you get the value. Okay. So in the same way, you have certain formulas which you have to remember for Laplace transform. So I tell you the functions and its Laplace transform values. Very important table. It's there in your notes. So these are just formulas. So Laplace transform of a step function, or it is just a constant value. Let us take step. Function is a constant. Laplace transform of a constant is given by k by s. K by s. Laplace transform of t 1 by s square. Laplace transform of t power n will be 1 by s power. Now t power n will be equal to n factorial by s power n plus 1. Laplace transform of t power n is n factorial by s into n factorial by s to the power of n plus 1. Next, Laplace transform e power minus at 1 by s plus a. E power minus at is 1 by s plus a. E power at is 1 by s minus a. Next, Laplace transform of sin t. Laplace transform of sin t. Sin, okay, it can be kt. It may be a constant t value or it might be with some k value. So k by s plus k, s square plus k square. K by s square plus k square. Next, cos kt. It is cos kt. S by s square plus k square. For sin it is k by s square plus k square. For cos it is s by s square plus k square. E power minus at sin kt. E power minus at sin kt is equal to k by a square. K by s square plus k square is for sin. For this you have plus k square. K by s square plus a square into k by k square plus s square plus a square is e power minus at sin kt is k by k square plus s square plus a square. Oh, I'm sorry. Extremely sorry. It's e power minus at sin kt, no? So k by s plus a whole square plus k square. S plus a whole square plus k square. E power minus at cos kt is equal to s by s plus a whole square plus k square. S by s plus a by s plus a by s plus a square plus k square. E power minus at cos kt is s plus a by s plus a whole square plus k square, and many more formulas you have. Please check it in your notes. So Laplace transform of constant is k by s. T power n is n factorial by s power n plus 1. E power minus at 1 by s plus a. Sin kt is k by s square plus k square. Cos kt s by s square plus k square. E power minus at sin kt is k by s plus a whole square plus k square. E power minus at cos kt is equal to s plus a by s plus a whole square plus k square, and so on. Many of others you have. Kindly go through the notes. And yeah, now moving to the problems. I'll be helping you all to solve 2 to 3 problems here. And before that solving, I have to tell you the Laplace transform for differentials. Laplace transform for differential equation or differential. So Laplace transform of Laplace transform of d f of t by dt. First order Laplace transform d of f of t by dt. Laplace transform is given as s into f of s minus f of 0. Next, Laplace transform of d square f of t by dt. Please remember these. It is easy to remember. So square, no? So s square. First function f of s minus, after s square it is s. After s, what is the value? Functional value 0. Minus square, no? Before that, after this you have a constant value which will be f dash of 0. F dash 0. Similarly, Laplace transform of d cube f of t by dt is given as first cube. So s cube into f of s. Reduce your value s square. After f of s, f of 0. After s square, s into again f dash of 0. After f of 0, f dash 0. Minus, after f dash, f double dash. Constant should be there, right? Yeah, so on it goes on. So Laplace transform of general equation d power n f of t by dt is equal to s power n into f of s minus s power n minus 1 into f of 0 minus s power n minus 2 into f dash of 0 and so on minus f power n minus 1 of 0. F of n minus 1 of 0. Nothing but if it is square, f dash 0. If it is cube, if it f double dash 0. You can see in the above example. This is the general formula. Laplace transform of differential d power n f of t by dt is equal to s power n into f of s minus s power n minus 1 into f of 0 minus s power n minus 2 into f dash and so on f power n minus 1 of 0 means that much times you have to differentiate. Okay. So now we will solve few problems on Laplace transform. So the first one, find the Laplace transform of the function d cube of s by dt cube plus d square 4 into d square x by dt square plus pi dx by dt plus 2x is equal to 2, for which x of 0 dx of 0 by dt and d square x of 0 by dt square is equal to 0. Indirectly, x of 0 is equal to x dash of 0 is equal to x double dash of 0 is equal to 0. He has given in the question. You have to find the Laplace transform for this function, where x of 0 is equal to dx of 0 by dt is equal to d square x of 0 by dt square is equal to 0. Indirectly, x dash of 0 is equal to x of 0 is equal to x double dash of 0 is equal to 0. This is given in the question. Right? Now, how to solve this? Now, applying Laplace, first step is to apply Laplace transform on both sides. I'll tell you step by step, listen carefully. So, first step is to apply Laplace transform. So, Laplace transform of d cube of x by dt cube plus 4 into Laplace transform of d square x by dt square plus Laplace pi into Laplace transform of dx by dt plus 2 into Laplace transform of x is equal to Laplace transform of 2 is equal to Laplace transform of 2. Laplace transform you need to apply on both sides first. So Laplace transform of d cube x by dt cube, and just we have derived it s power. So it is s cube into f of s, x of s here, it is not f, it is function x, right? So x of s minus s square into x of 0 minus s into x dash of 0 minus x double dash of 0. This is the Laplace transform of d cube x by dt cube plus 4 into Laplace transform of d square x by dt square. First square function. So s square into x of s minus s into x of 0 minus x dash of 0 plus 5 into Laplace transform of dx by dt s into f of s, sorry, x of s minus x of 0 minus x of 0 plus 2 into Laplace transform of a function x. This is the function, not x, okay? This is not x. Laplace transform of a function x. It is nothing but x of s. Laplace transform of function f of t is nothing but x of s. So this is x of s is equal to Laplace transform of a constant k by s. So it is 2 by s. Laplace transform of a constant, that constant here is 2. So k by s, k is 2, so 2 by s. Right? Now in the question it has given that x of 0 is equal to x dash of 0 is equal to x double dash of 0 is equal to 0. X of 0, x dash of 0 is equal to x double dash of 0 is equal to 0 given in the question. So your x of 0 is 0, so this term becomes 0. X dash is 0, so this also becomes 0. X double dash is also 0, so that value also becomes 0. So all your functional values of 0 are 0. Right? So remaining terms are s cube into x of s, s cube into x of s plus 4 into s square into x of s plus 5 into s into x of s plus x of s is equal to 2 by s. From this take x of s common, you get 2 by s into s cube plus 4s square plus 5s plus 1 is the x of s value. X of s value. So this is the function x of t for which the Laplace transform x of s is given by so and so. So this is how you determine the Laplace transform of a given function. First one, find the Laplace transform, applying Laplace transform both sides to the given function. Then substituting the Laplace transform formulas, given conditions to be applied, x of 0, x dash and x double dash is 0 in this case. In some cases you might have certain values also. So you will substitute those values and take x of s common and rest of the term you will send to the other side, so it becomes divided. So x of s is 2 by s into s cube plus 4s square plus 5s plus 1. Is it clear? So in the same way, I'll be giving you 2 to 3 problems. You have to solve them and send it. And if any doubts, let me know. Okay? Yeah. First one. Solve the Laplace transform. Find the Laplace transform of the function x of t is equal to dx by dt plus 3x is equal to 0. Where x of 0 is equal to 2. Where x of 0 is equal to 2. Second one, find the Laplace transform of the function x of t is equal to dx by dt plus 1. Sorry, dx by dt plus x is equal to 1. For the function dx by dt plus x is equal to 1, where x of 0 is equal to 0. X of 0 is equal to 0. Is it clear? Sorry, these are not the functional. Sorry, right. Determine the Laplace transform for the given function dx by dt plus dx is equal to 0, x of 0 is 2, dx by dt plus x equal to 1, where x of 0 is equal to 0. In this, the question is to determine the Laplace transform of the given function. That means f of s you have to determine. That means in these cases you have to determine x of s. Now, till now it is only applying Laplace transform. In the questions you will have solve the function. Solve the function. in that cases, what you have to do, after finding x of s, you also have to find x of t. The given question will be in differential form. That means solve the differential equation he will give you. Means x of s you will get, then you have to apply inverse Laplace transform and find x of t. That I will explain you one problem. Before that, you have to practice how to get the x of s value. That is the applying Laplace transforms to the differential equations. Practice those. Okay. Now, Laplace transform of the functions are done. Now we have to see, you have to solve the differential equations. You have to solve the differential equations. Up till now you have seen, find the Laplace transform for the given function. Find the Laplace transform for the given function. Means you have to find x of s. Now here you have to solve the differential equations. Nothing but see the questions only. If you get confused with the questions, your answers will go wrong. You might lose marks. So the fact is, x of s is nothing but the Laplace transform of a particular function. So in the question, if it is saying that determine the Laplace transform of a given function, then you have to stop at x of s. In the question, if it is mentioned solve the differential equation or solve the given function, then you have to calculate x of s, then apply inverse Laplace transform and calculate x of t also. We'll see that example. Solve the differential equation. D square x by dt square plus 2 dx by dt plus 2x is equal to 2, where x of 0 is equal to x dash of 0 is equal to 0. Given that, solve the differential equation for these conditions. Okay. Now, what we have to do is, you have to find, solve implies to determine x of t. You have to find the function here. This is the differential equation of this function. So, basically Laplace transforms are generally used to solve the differential equations. So here Laplace transform of this differential equation is, you have to find out. Then inverse Laplace transform to find the functional value of x of t. Solving is, you have to find the x of t value. Okay. So now, first, as usual, the first step is applying Laplace transform on both sides. So Laplace transform of d square x by dt square plus Laplace transform of 2 into dx by dt plus 2 into Laplace transform of x is equal to Laplace transform of 2. Applying Laplace transform on both sides. So I directly solve. Hence, I will not write the step Laplace transform. I am just saying that. Okay. So Laplace transform of d square x by dt square. First step, applying Laplace transform on both sides. So Laplace transform